Hello, my name is Dr. Glen Rodgers. I'm a professor emeritus of chemistry at Allegheny College and the author of Traveling with the Atom, a scientific guide to Europe and beyond, published in 2020 by the Royal Society of Chemistry. It's a great pleasure to take this occasion to tell you a little bit about Traveling with the Atom. First and foremost, this book is about traveling in Europe to explore physical landmarks commemorating one of the most significant and enduring ideas in the history of humankind, the atomic concept. In addition to listing, describing, and rating hundreds of places in more than 20 countries, the book recounts a wide variety of fascinating stories and anecdotes about these scientists, their workplaces, their experiments and equipment, as well as their personalities, colleagues, and families. For those of you who are scientists, the background the book provides will serve to jog the memory and remind us of what we might have recently studied in school, or perhaps what we read or studied a number of years ago. For others not so familiar with the history of the atom, it will provide enough of a framework to better understand the significance of a given site, experiment, person, or piece of equipment. This book then is about two types of landmarks: the temporal landmarks of the history of the atomic concept, and the physical landmarks that have been preserved all over the European continent to commemorate this achievement. Now let me give you a little background about how this book came to be. Starting with a sabbatical leave in 1998, my wife Kitty and I have taken some 13 trips abroad, during which we have explored an astonishing variety of landmarks all over Europe, and a few other countries like the United States, Canada, and New Zealand that celebrate the discovery of the atom. In 2002, we led a travel seminar entitled Traveling with the Atom, London and Paris. This was a group of 7 Allegheny College natural science majors who traveled together for 2 weeks. This group picture was taken in front of the crocodile carving honoring Ernst Rutherford, who first proposed the nuclear atom, at the old Cavendish at Cambridge University. I should point out that Katie, the young lady pictured in red in the group photograph, was a graduate student in the history of science at the university. She is representative of our efforts to engage archivists, museum directors, historians of science, and other local experts to help us when we visited various sites. Katie devised and led our group on a splendid tour of scientific historical sites in Cambridge. In 2004, we co-led with Anthony Moskwa, a professor of economics at Allegheny, another travel seminar entitled Traveling in the Liberal Arts Tradition, Berlin, Leipzig, Warsaw, and Prague. This group picture was taken in Freiburg, Germany, in front of the gilded gold memorial to Clemens Winkler, the discoverer of germanium, an element that Dmitri Mendeleev had predicted should exist between silicon and tin in his newly minted periodic table. Winkler discovered it and therefore had the privilege of naming it after his fatherland. In 2005, Kitty and I retired and we're on our own to explore as many scientific historical sites as we could in the following 15 years. As you can see, we were always on the lookout for an occasion to raise a toast to these scientists and their work. Ludwig Boltzmann, sometimes called the martyr to the atom, is an amazing character in atomic history. There are several stories about him in Chapter 10 that I hope you will enjoy reading. Look for the story about building a sewing machine for his wife, Henriette. So, over these more than 20 years, we have found hundreds of Traveling with the Atom sites that are now listed in the 19 chapters and 550 pages of the book. For each site, I provide a physical address, GPS coordinates, and an appropriate description. In addition, each site has a ranking from 1 to 5 atoms. Not asterisks or stars, mind you, but atoms, depending on its importance and how much fun it is to visit. Just as an example, here's an entry for Wilhelm Röntgen in Würzburg. Note that it is a 4-atom site. Röntgen discovered X-rays in 1895. His discovery started us on the road to the modern atom. There are also more than 100 maps or charts in the book. Here's the map showing some of the Röntgen sites. Another useful feature of the book is a detailed place index to help you plan your actual and, perhaps more appropriately in these COVID times, your virtual trips that you can enjoy while sitting in your easy chair beside a roaring fire in your fireplace. The place index will lead you to sites directly related to the history of the atom, but also to spots that you should not miss while you're in the area. Some of these might be non-atomic sites that no scientific historical traveler should miss when she is in the area. Two examples of these are the Pasteur Institute in Paris and Charles Darwin's Down House southwest of London. Others might be completely non-scientific places, like the honor graves of the great Austrian and German musicians in the same cemetery where the renowned Ludwig Boltzmann's headstone boasts of his great equation S equals K log W. And then there are just fun places, like the Café Landmann in Vienna, the coffee house of scientists and the great psychologist Sigmund Freud. Or the Carlsberg Brewery in Copenhagen, not only where Niels and Marguerite Bohr lived in the honorary residence for 30 years, but also the home of Carlsberg Pale Lager and their richer elephant beer. Be sure to go by the Elephant Gate, the landmark entrance to the Carlsberg Visitor Center, with its 4 swastika-clad granite elephants. Or St. Michael's Mount, the tidal island near Land's End, England, that inspired the great Humphrey Davy to write poetry in its honor. Okay, back to the scientific sites. As noted, each one is rated from 1 to 5 atoms. This is a good place for me to list just a few of my favorite 4 and 5 atom sites. They include the Royal Institution in London, the James Clerk Maxwell Foundation in Edinburgh, Rutherford's Den in Christchurch, New Zealand, the Bohr Institute in Copenhagen, Einstein's Flat in Bern, Switzerland, and the Mendeleev Museum and Archives in St. Petersburg. In addition to listing these places as noted previously, the book is full of poignant, entertaining, and often humorous anecdotes and stories about these scientists, their families, and their work. Some reviewers say it is these stories that make the book so special to scientists, as well as to their students, friends, and companions. Two of my favorite stories are the fate of the Spanish professor when he was knocked flat to the floor while visiting His Excellency Enrico Fermi, sometimes referred to as the Pope of Physics, at his laboratory on Via Panisperna in Rome. Or another is about Einstein's manly good looks and his 1914 arrangements with his first wife, Mileva Merrick, to receive the funds from the Nobel Prize that he was confident he would win. He won the prize in 1921 and did, in fact, keep his promise to her and their 2 sons, Hans Albert and Edward. In summary, before we get to some of your questions, I hope that when you read Traveling with the Atom, you will find that there is something magical about standing in the actual locale where scientists revealed the atomic nature of matter, where a pioneering atomist did her best work, or where museums display and demonstrate the actual tools by which nature yielded some of her atomic secrets. Let's go on now to answer a few frequently asked questions. Can you tell us one of those poignant stories or anecdotes and how they are connected to the history of the atom? Well, let's take Robert Bunsen, for example. I venture to guess that many of you know about his Bunsen burner. You may recall it from your chemistry classes, and were even a bit afraid to light and adjust one the first time you tried it. Or as an instructor, you were pleased to show a student more about how it works. But I wonder, do you know about the toasted cheese? This slide shows a Helen Beatrix Potter watercolor of mice using a Bunsen burner to toast the cheese for their sandwiches. Potter was the niece of Henry Enfield Roscoe, who helped Bunsen design this burner. If you look closely, you can see the mice doing many other things as well. So, why did Bunsen invent his burner? Well, he knew that instead of putting a piece of cheese on the wire, if one puts a metal salt on it and inserts that into the flame, each salt produces a beautiful, characteristic color. Bunsen didn't want a burner to contribute any color to these so-called flame tests, so he invented a burner that had a colorless flame. When his colleague Gustav Kirchhoff suggested that these colors be put through a slit and then a prism, they produce what are called line spectra, which, being unique to each element, were soon recognized to be fingerprints of atoms. To add to this story, Joseph Fraunhofer, a few decades earlier, had devised excellent prisms that he used to record the spectrum of the sun. His solar spectrum had a series of dark lines, which are still called Fraunhofer lines. It is important to note that Fraunhofer had no idea what caused these lines, but Bunsen and Kirchhoff almost immediately matched them up with their bright line spectra and announced that they could tell what atoms exist on the sun. There was iron on the sun, and sodium, calcium, and so forth. Those are a few of the stories and anecdotes behind the great Robert Bunsen and his colleague Gustav Kirchhoff, who were the first to identify what atoms are on the sun. There are a number of Bunsen and Kirchhoff sites in Heidelberg, Germany. Here are a few. Readers have also asked about how we planned our many trips and how we kept track of what we saw there. For each trip, we constructed an elaborate, custom-made travel guide that contained everything we needed to know about the upcoming trip. Day-by-day itineraries, reservations, maps, and correspondence with the archivist guides or scientists who we were scheduled to visit with at each site. To keep track of what we saw when, I kept elaborate daily journals in which I would write long passages each night. Sometimes I drew diagrams of things, objects, and little maps, for example, that I wanted to recall. Here is one with some drawings. You can see that I enjoyed a double espresso when writing in this one. In my opinion, traveling doesn't get any better than this. Another frequently asked question is, can you tell us a little more about the place index? Well, the place index is 13 pages long, with many detailed entries, as I mentioned earlier. Here's a close-up for the entry for Como, Italy. In particular, we see a listing for the Tempio Voltiano, or Volta Temple. Bold print indicates a 3, 4, or 5 atom site. Italics refer to figures, and the italicized CH indicates a chart or map on page 233. So what is the Tempio Voltiano? It's a 5-atom site and a beautiful neoclassical temple which serves as a museum honoring Alessandro Volta, the inventor of a battery that produced for the first time a continuous electrical current. Here's figure 9.4 on page 234 showing the temple. Touring it is an amazing adventure for scientific historical travelers and their students, friends, and companions. Here's chart 9.2 showing the location of many Volta sites in Como, including the Temple Voltiano. Note that there are 9 Volta sites shown here. Statues and plaques and a museum, piazza, cafe, cemetery, and even an inland Volta lighthouse that emits a rotating green, white, and red light celebrating the Italian flag, for heaven's sakes. Sitting on top of a hill, it was built to celebrate the grandeur of the great Alessandro Volta. Now, that's not your typical lighthouse. Travelers know that sometimes things don't go quite as well as we expect them to. Perhaps you could tell us about one incident that surprised you the most. Well, in Westminster Abbey, one of the students in our travel seminar was interested in seeing the actual diamond-shaped memorials to Ernst Rutherford, who discovered the nucleus, and J.J. Thomson, who discovered the electron. It turns out that their ashes are buried under the elaborate altar in the nave of the Abbey. That area is roped off by beautiful, thick, purple velvet ropes that prevent public access. John, my student, sought the help of a verger to take him to the altar table. I saw them start to lift the ropes and rushed over to join them. The verger sternly said, "Oh, no, sir, you are not allowed in here." However, my student was cool, calm, and collected and just said, "Oh, it's okay, he's with me." The verger saw fit to allow me to go with them, and we went in, lifted the thick violet cloths covering the altar, and viewed together the grave sites of 2 of the most important men in the history of the atom. Another questioner wants to know how she will know if the information in the book is up to date. Great question. I'd invite you to go into my website at www.travelingatom.com and go into the forum and ask a question. The forum is a place for travelers to exchange travel information. You could also email me at the address provided in the contact section of the website. Finally, under frequently asked questions, could you read us a short excerpt from the book? One reader has urged me to read a few sections from the beginning of chapter 7, entitled Scientists at the Heart of Westminster Abbey. He said it had an air of mystery about it that he enjoyed. See what you think. So far, we have made only passing references to visiting one of the most prominent houses of worship in all of Europe, the magnificent Westminster Abbey in London. As scientific historical travelers, we might pinch ourselves as we queue up to get into the great structure in the heart of London. In the line, we, like others, talk excitedly among ourselves, but once we get inside, our shoes clack on the stone floors. Our eyes are drawn to the great vaulted ceiling, and our voices, somewhat muted now, echo off the centuries-old walls covered by plaques, inscriptions, and statues. We travelers with the atom, like everyone else, will have to follow the prescribed route, and we will certainly recognize and appreciate the memorials, graves, statues, and other reminders of the poets, musicians, statesmen, royalty, and other honored here. However, primarily, we will be on the lookout for burial sites and memorials for scientists, particularly those involved with the history of the atomic concept. So let's get started.